Assalamualaikum warahmatullahi wabarakatuh. In this video, I'm going to present a practical example related to the application of Kruskal Wallis test. Here we have a table that exhibits the cortisol levels in three groups of patients who were delivered between 38 and 42 weeks of gestation. So here group 1 was studied before the onset of labor at elective caesarean section. Group 2 was studied at emergency caesarean section during induced labor, and group 3 consisted of patients in whom spontaneous labor occurred and who were delivered either vaginally or by caesarean section. So basically all the long sentences that you just saw, they are just simple explanation about what is group 1, group 2 and group 3. But the key point here is we have 3 independent groups, so our K here is equal to 3. So that's the main point that we need to take. Now significance level is 5%, so that is our alpha, and the question is asking you to decide if data here provide sufficient evidence to indicate a difference in median cortisol levels among the three populations represented. So again, well, we have several information here. First, K is equal to 3. These are the number of independent samples or independent groups. This is also another important information. Here is the word or the keyword related to alternative hypothesis. Because of the word difference is not equal, so we are looking at to find inequality in median cortisol levels among the three populations. And with that, we can start off our procedure by writing down the hypothesis statements, and we are going to begin with here is the first step, writing the hypothesis statements. H0 here is well, we can write down properly like this: the median cortisol levels are all the same. So the keyword here is same or similar or equal. So this is the keyword used in the construction of null hypothesis. The median cortisol levels are all the same among three populations represented. So I hope you can see that this construction of statement here comes directly from the last statement here, except for the word difference, because this word here will be supplied to the alternative hypothesis statement. Okay, and an alternative is just the opposite of null hypothesis, or we can simply write down at least one median cortisol levels is different. So we are saying that at least we have one group here with different level of median, with different level of cortisol value. The median of cortisol level here is different for one group at least. So that's it. That's the first step. The second step is to come up with a test statistic, and for that we need to look at our data set. Here is our data set, the observations from all the groups that we have to rank accordingly. So of all these observations, you need to look at which one is the lowest, and that will be given the first rank. So here is the lowest value. This is 1, and then you need to cross-check all the other values from other columns. That can be quite hard to do if you have a big data set. Well, from here you can see the next highest value is well, 207. This is rank 2, and then again you have to go on and check So here is 3. I think for me personally, I think it's a bit difficult when you have to, sort of look at a lot of data set in such a random order in order to find which one is the next higher value to be ranked. So because of that, well, I personally prefer to do it like this, to rearrange my data set. So here is my arrangement of data set. You can see for group 1 here, well, I prefer to rearrange it in ascending order. So here is the lowest value and 454 is the highest value. So basically what I did here is just rearranging all the values in group 1. So similar for this one, the similar process is done for data in group 2, basically rearranging from lowest to highest. And finally the last one for group 3, and I'm just going to rank the observation based on this new arrangement. I think it makes my life a bit easier, because then I have to my cross examination of all the values can be done quite easily and systematically, at least in my opinion. Okay, up to you to rearrange or not, because this procedure is really according to your preference. If you prefer to do it like this, you can. If you want to omit this step also, you can. It doesn't matter. Okay, now so let's say I have this new rearranged values of my observations in group 1, group 2, group 3. What I can do next is I can start ranking the observations. Okay. What color? This one. Okay, so here I can see that out of all these 3, this is the lowest, and then 207, so this is 2, and then this is 3. Next we have 355, 362, 343, this is 4. So all the 200s must be ranked first, because this is 355, 362. Okay, so we can forget about that observation first. Okay, next. So this is 6, this is 7, this is 8, this is 9. So you see it is quite easy to rank afterwards. And then 339, 34, this is 10, 34, 355, this is 11, this is 12, 356. Okay, next this is 300, 300, this must be 13. And then this is 14, this is 15. Okay, this is 16, 17, and then this is 18, 19, 20, 21, 22. So you can see it gets a bit easier to rearrange and at least avoid some mistakes in ranking the observations. Okay, so if you think that this is a good idea, then go ahead and try to employ that during your process of applying the Kruskal-Wallis test. Okay, now in order to get the test statistic, well, first of all you need to get the sum of the ranks that you just obtained. So 1 plus 3 plus 4 plus 5, 6, 7, 8, 9, 12, 14. The result here is 69. So this is the value of R1, the rank, the sum of the ranks in group 1. Similarly, 11 plus 13, 15, 16, 17, 18, you will get the sum of rank in group 2. This is equal to 90. 2 plus 10, 19, 20, 21, 22 will give you the sum of rank in group 3. The answer here is 94. Please verify that the results I give here are true. Okay, so the second step, okay, step 2 is to obtain the test statistic. The test statistic is given by this formula. So this is H 12 over n times n plus 1 times the summation of Ri squared. Well, you just got the value of R1, R2, R3 over there, over Ni for I equals to 1 until K. So this depends on how many groups you have, minus 3 n plus 1. So what is the value of n? N here is the total sample size. Over here, the sample size is Ni N1 for this, the first group here, the sample size is 10. This one here, the sample size is 6. For this one here, the sample size is also 6. Therefore, n is 10 plus 6 plus 6, which is equal to 22. So 12 over 22 times 23 n plus 1 times with, so the process here will be done in a bracket here. We have R1 when I equals to 1, so we have R1 squared over N1, which means we're taking this value 69 squared over 10. So that is for I equals to 1. When I equals to 2, you will have this partner here, this pair, which is 90 squared over 6, plus when I is equal to K, or the last one, which is K equals to 3, we'll get this pair, which is just 94 squared over 6. So that is the process given for this one. And you will minus this with 3 times n plus 1, which is 23. So that's the process. Plug in all the values here in your calculator. You'll be able to get the value of H is equal to 9.232. Okay, so that's the process of finding the test statistic. The next step is, the third step is to find the critical value. Okay, so step 3, you need to find the critical value, and for this purpose you need to refer to the chi-square distribution table, obviously, because your sample size is quite big. It is, more than 5 for each group. Okay, so you can refer to this chi-square distribution table. And well, we know that alpha is equal to 5%, and degrees of freedom is k minus 1. K is the number of groups, which is 3 minus 1, which is equal to 2. Therefore, if you look at degrees of freedom 2 and 0.05 for 5%, the critical value is 5.991. So I can represent it in terms of the graph here. Basically, at this point, 5.991, the area to the right here is 0.05. Okay, that is what it means by all these values that you see on the table here. Now, step 4, we are going to decide whether the null hypothesis should be rejected or not. So we're going to make some decision here. So we will compare the test statistic with the critical value. The test statistic here is 9.232, and the critical value is 5.991. You can see the position of 9 is somewhere here, so it could be it will be on the right side of this critical value. The position of critical value is 5.991, so 9.232 will be somewhere here on the right side. Because of that, okay, so since H is greater than the critical value, we decide that the null hypothesis can be rejected. Okay, so since H is greater than the critical value, H null can be rejected. Okay, so that is step 4. Now for step 5, we're going to make a proper conclusion. We can say that at 5% significance level, there is enough evidence to say that median cortisol levels is different. Okay, and maybe we can wrap it up with a conclusion that answers the question given in the example. So therefore there is sufficient evidence. Okay, so we can continue with that. There is sufficient evidence to indicate a difference in median why I keep on saying median cortisol levels among the 3 populations represented. I'm running out of space and my handwriting is really bad, but anyway, I hope you get the idea. Okay, let me just go again all the words that I've written here. At 5% significance level, there is enough evidence to say that at least one median cortisol level is different. So this comes directly from the alternative hypothesis statement. And then to make it nicer, I just would like to wrap it up by answering the question given in the example. So I can say that there is a sufficient evidence to indicate a difference in median cortisol levels among the 3 populations represented. This sentence here comes directly from the last sentence of example that you've seen just now. Okay, so I think that's all. Before I end this video, let's talk about finding the p-value. Okay, so let's say the question is asking you to find the p-value. What's the p-value? So what is the p-value in this case? So in order to find the p-value, you need to know what is your test statistic. So the test statistic is H 9.232. So you need to identify the position of 9.232 on this line here, because our degrees of freedom is 2, remember? So degrees of freedom is 2 based on k minus 1, 3 minus 1. So identify where is the position of 9.232 on this line right here. So obviously you can see that 9.232 will be the value between 9.210 and 10.597. Okay, let me just explain by simple graph what are these values actually all about. So again, if we have this graph, so this is the chi-square distribution, this is at point 0. The position of 9.210 could be right here, 9.210, and it corresponds to having the area to the right equal to 0.01. So that is the area or the probability. Now for this one here, 10.597. It could be somewhere here, 10.597. Basically, it says the area from this point to the right is very small, smaller, which is 0.005. Therefore, the position of your test statistic, this is the test statistic, the position here is between the two values here. It could be somewhere here. So this is 9.232. So the p-value here is looking at the area from this point to the right. And you can see, of course, the purple area here is bigger than the green area, but is less than the blue area. The blue area here is the large area because it begins from this point to this one. Yeah. So this is the area is 0.01. For purple, for the position of our test statistic, we are looking at this area to the right. Yeah. So the area here is, the purple area here is smaller than the blue area. And of course, for this one here to the right, this is the smallest area. So p-value is just the p-value. We can say it will be between 0.005. Clearly, the purple area here, this one here, the area here is bigger than 0.05. So p-value bigger than 0.005, but smaller than 0.01. Okay, I think that's all for now. Thank you very much for watching, and I'll see you in the next video with more example related to the application of Kruskal Wallis test.